Yeah, today is we're going to cover first this morning is a PIDs. So I was I was kind of just this morning I was think about that which ways maybe better to approach to get into the PID. Thank you. And well, I decided just like maybe you may need some like some references after these classes. So I just decided create the one. This is I select the custom program. So this is not related with any unit selection. This is just full custom program. And then I adding like, oh, well, maybe what we can try, I don't know, as long as the time's allowed today, I'm going to target on, cover up several PID. So yesterday, one gentleman mentioned about that, the PID, try to customize it to put some different unit or different application like flow applications. So unit is GPM. And then as you know that as when you Q&A, all the bypass control is what? Based on condensing water is the temperature. And then sometimes like maybe pressure. So there is no actually water flow control. Well, that's when you Q&A, that's only, there's, we put some limitation, some possibility, but in the, reality, there is more, maybe other application that maybe require different, units and different processing time and so on. So that's why it's like you have to able to change or modify or create your own pit loop. Doing that is like, I'm not really recommended to create a brand new if you're not exactly sure what is PID is. Then just, go to usually, okay. Yeah, this morning I just gonna just put this one in to show you guys that, CCT can have also trend, that's all. So this is nothing. Flash is update. So you hit this guy, and then it'll just show all the records so far. So right now, I'm just monitoring that. What's the chill water valve output is, and then every 5 seconds. So anyway, this is another way to do. Okay. All right. So now say, hey, you have that, say, okay, just let's go to, where's my, let's do bypass valve control. AO from that, CGM, whatever. And then now this is all depend on, say, that the flow. So you're monitoring the flow, it doesn't matter which in and out, but let's just say that you're monitoring now is like a flow, GPM, water flow. And then when GPM, like it say that, let's say condensing water flow set point. I'm just making the, just guessing, so you don't have to, this is not really standard or anything. Say, condensing water flow set point is to say, oh, well, they want to make a 200 GPM to maintaining to go to out, whatever. And then this is called, return, which is bypassing it. So doing this, meaning is when condensing water flow, this one is, if this is exceeding 200 CFM, we want to open up the bypass to return side so they can, just come back. So just, only shooting out at the 200 GPM. So just making this, pit loop. I done that this morning, just kick, but this one is, I create my own full, but you don't have to. Just like selecting, say, well, nearby that things like, okay, how about bypass, just you hit the, oh no. Say, what is it, what else? Chill water. There's anything bypass things? Condensing water bypass? No, they don't have it. Huh. Surprise. We don't want to hit recovery. I'll just say maybe just pump, secondary pump control. Secondary pump control. I'll just select this one, and then I'll just change the name. That is, okay, condensing water bypass valve control by water. Condensing water flow. Well, yeah, why not? Any name is fine. So now this one is, I selected it from that the one exists in our CCT, that option, the control output logic side. And I created it, and then when you go in there, see here, it is, if you look at that, all the attribute here, the attribute is PSI, and direct acting is false. Direct acting false means what? Process value is go up, output is going down, so it's reversing. So pump is okay, but anyway, this is all related with the pump. Now you can convert that easily to the GPM. And how to do that is just, instead of coming here, you just come here and just go view detail. First, hit the unit, make just kind of a sorting, and then any PSI, change it to GPM. GPM. And if you don't want to even display precision 1/10, then you can put the 1. It doesn't matter. GPM is, they don't care much about the 1/10 of the, any precision. So, and then here, process ID is a PSI right now. Well, hey, I'm not handling PSI, so we put the GPM here. And then pump differential pressure. No, we are not doing the differential pressure control. So we do have a water control. And then if you're looking at it, oh, there is no water control, then don't worry, there is others. Other meaning is like any others. So put it in. Any other things that we have to be changing it? Oh yeah, that is like, that's the other side. Okay, so now you apply it. Now you look at your connections attribute. So now it's like a clean. Okay, oh yeah, I got all the changes to GPM and so on. And default value, don't bother default value. And sometimes like if you really want to get into everything clean, and then just go view detail, when you fix that, when you change the fix that unit, I'll just, okay, so what is the process range is right now 40, 10, and 10, and process range is 10. Process variable, I say 0, I'll say 0, just leave it alone. Process range meaning is what? Process range meaning is like usually the control ranges. And is that has to be a really precisely, perfect? No. So usually GPM, we are ranging, say, oh yeah, we are controlling now 200 GPM, but the gauge say the maximum, maximum range is 250. 250 to 20 is, 200 is what, about 50, right? So give them a slack, then you can put the throw to 50. It's not hurting because it doesn't care right now. Once you get into it, when auto-tuning it, and then they'll grab that effective process range and all the other parameter. So when you kind of let it run for that, once you've done it, and then let it run for like several hours, and then you can collect all the value, and then you can write those value into, the pre-PID side later on. So to start up, I wouldn't even touch even 40 because that's not doing anything. So just leave it there and apply. And then process variables now, we want to control the condensing water flow, so you have to connect at the input. Make a connection. I already created this condensing water flow. Set point, condensing water flow set point. And then from here, oh yeah, that's okay. You can come in here. So they asking, is this direct acting or reverse acting? So now, currently false, meaning is what? It is actually reverse acting because the pump is reverse acting. But a valve is what? When GPM is increased, you want to open up the valve, right? So that's the direct acting. So when values go up, output go out. When value go down, output go down. That's the direct. So they're just, acting same way. So then, okay, now I want direct acting to true. Yes. So now, where that this affected into it is actually under control. So now we got the process range. If you kind of, this is another, I think that most people know, but if somebody may not know, if you cruise around at your mouse at the middle here, it'll say, oh, what the description is. But if you come more toward to the, this connection side, they will tell you what is the current default value is. So that's another tip. And then you instead of double click it to find it, or you can just make a half screen to see it, and you can just just bring around to see it here. Now process IDs now are others, and so on. Anyway, to just double click on the PID preprocessors and just view detail. That right now is default is a GNT because always they are GNT. No matter what you're making it, that the pit loop, they always default GNT, but you don't care because it's right now why? Why we not care much about it? Because we already connect that process ID from the external port that we created it for the other. So that is actually going there, put into the present value. Just GNT is just default value. But if you don't like to see that unmatched that process ID and then unit, then you can just change it. If that is bother you, then go there, just change it to others, change it to GPM, and then just leave it everything else same. So, that's it. That's all you need to do. So now, let's simulate it. So to simulate it, you don't need anything, right? You don't even need sometimes input, because I just made it up the condensing water flow and condensing water flow set point. But when you simulate it, you don't have to connect to anything. Just simulate it and then just command from that to all input side, see what happens. Yeah, please, when you play around with it, don't put it into 5. that, usually when the CCT starts the first time, they usually stick into the 5, put into 1. If put into 5 is too fast. Especially valve, the valve, bypass valve, also, you need a little bit faster responded. Because when that, flow control, when his flow is coming in more, say, somehow that, pump pitch up and then just pushing off the more water, and you want to, valve to respond faster. Otherwise, it's what? It's going to be a what? It's just going to shooting out the whole field, and then, just like maybe you get, kind of water sludgings. So, by now, we are in control. I believe that I put the control, yeah, good. But anyways, in control, as you see it now, is right now set point is a 200 GPM, and then process variable is a 0. Nothing, no reading, so it's okay. Now you can override and command the process variable. Say, just curiosity, 200. Just make a match it. And then, there's a 0. Am I doing one that we just did it? Oh, yeah, okay. I thought I did. Okay. So now, like this portion side, PID processors. These PID processors actually handling out that effective, you see here, effective time, whatever. But when you open up, and top side, we have a process ranges. Look at the bottom, effective process ranges. Right now it's a 40. And then effective time constant. So they are all same, right? But the sum of them is different, right? Proportional band. Right now it was a 16, but 29.1. See, they already start to calculate it. That's why when you're doing the auto tuning to get the some, pretty close value for all the parameter for the PID, you have to let that things to control, at least I recommend to say 4 hours, at least. Let it run and just, do something else, then come back. So I usually let the, kind of guiding the, our field tech that is like, when you do the commissioning at a project, maybe a day, maybe there is a box or air handler unit or their pump, whatever, just make a schedule. So which one is maybe easier? Usually, box, isn't it? Then before you attack into boxes, now you have a planning to control that the pump, then let the pump to run. And then come back, do your VAB, whatever, and then go back after maybe half day, go back there, target on that pump commissioning. Because at that time, because since that several hours running, this value is maybe at least get some pretty close all the parameter. Then you have to be copy that all the value, not default value, but the current value, all copy value, copy that snapshot usually. I recommend the snapshot and then put that into the default value up here. Effective process range value to there and so on. So once they're done, even down here, all the default value, change it. Then this pit loop parameters right now, it is actually got that the value when you do the first commissioning phases. But after for a while, it can be changing it. It keeps changing it because all based on the delta RI and so on. So it'll changing it. But to get that first initial value, at least it'll protecting you in case that sometimes like, okay, so in case I never see it, but in case they can delete the whole loop and then adding another one, then at least you got that data snapshot, screenshot data, and you can put it in. But if you don't have any, then you have to restart again. So yeah, just using that the screenshot a lot and then save it based on the project. I usually just myself, I create the project number because I handling my projects just like I cannot remember everything. Sometimes I don't even remember my number. So I just handling it in a project folder, and then I put all name, number, whatever, and then inside I put all kinds of documents and drawing and all kind of stuff. So I just throw in there, just make another folder and throw in there for the commissioning data, and then I just throw there. So in case if things happen, it can be happen. I know one guy is like I set up the like it was quite a while ago, but I set up all networks and an ADS I set up done, and then guess what? Accidentally somebody delete the whole damn my database. I mean, it was like a whole 1 week work. But good thing is that I had a backup. But the backup is only cover that when I backupped it. After that, it blew up. But it's still better than nothing, isn't it? So please backup. Backup when you do at the job site. Okay, time to go home. Backup. Everything what you got is a backup. And then any data like this, a screenshot, snipping tool. Capture it, save it under whatever your project file, a project folder, save it. So anyway, this is the way to do it. Now we're going to come out. Now I'm going to give this one to say 205. Yeah. Why is 100? It was already 100. Oh boy, that's not good. 195. Didn't I 200? Why 200 went up to 100% output? That's really weird. Huh. Yeah, set point is 200. No.
Yeah, go 210 on the process variable.
Oh, yeah. No. Like we said, hold on, let me see. Did I say that the direct acting? Yeah, true. So direct acting is a true, so it shouldn't be go up there.
It is if you're under, your process variable under.
Oh. Yeah. What am I doing?
210.
Yeah. Did I do that? Oh, yeah, but I did a 200. They should be satisfied, stated. That's what I'm saying. When I started it, didn't I give it to 200? No, I stopped. Good. Okay, just give me a second. So, yeah, it's open. Okay, I go say 0. Because when 0, it shouldn't open.
Time constant.
Where is my time constant is what? Time constant is 720 seconds. It's others. Okay. Anyway, it too slow. In these cases, we know that is this whatever that the existing one is may not properly approach it. So let's do the other one, the one that I create this morning. I'm gonna go command to control. And in control. Okay, so process set point is 200, process value is 0, and it's still 729 seconds, whatever. And then now I'm going to increase the process variable, say 201. The set point is 200. Because that the time constant might be 720 seconds and 900 seconds, because zone temp is more longer. But those things it is initial. Right now it is started, so it should be changed. But sometimes like you need a more process control, more faster. Then that time that you need a manual tuning. That manual tuning value is. You have to deal with all here, proportional band, integral time, and so on. But right now, sampling time, what's the interval? Oh, interval is 60 seconds. I don't like that. So now it's just wait, and then boom, open up. So it's not good. Then how about this way? We change this guy to, instead of other, I want to go to say discharge air temperature, a process ID and give same units. So now it is a discharge air temperature, discharge air temperature process ID. Because I'm lazy. I don't want to go to the manual tuning. Then you can just pick up, just like maybe discharge temperature control process ID or pump differential process ID. Airflow is, I know airflow is maybe another way because it's a flow. So now process variable is, they say 180, whatever, bring down. Now see, is the sampling time is only 12 seconds because since we changed it to the discharge temp process ID, look at here, that interval, which there is a period is just a bring down to 12 seconds, and then time constant is what right now? Time constant is a shrink down to 120 seconds. So anyway, you change the process ID to fit to that control. Now, you say this is okay, pretty decent. Now, okay, this maybe work, but still, take a time. But anyway, you don't like this, then you have to do the manual tuning. To manual tuning is more need attention and going there. When you require manual tuning, I usually put all the input, float input, and then just link into each parameter, so I can expose that. I mean, at the instead of coming in here, I can put at the network. In constant value, so I can keep changing it from the main page. But this case is only one, so we're not worried about it. So go view detail. And then, okay, I don't want the standard tuning anymore. So let's just false. Process ranges, okay, process ranges, let's say, I what, 50, whatever. And then time constant, I don't want to wait this too long, 124 seconds, whatever. So I said 30 seconds. Process that time. I'll explain to you what is all this, but let's say, okay, so process time is only 10. Proportional band. So always you look at the proportional band and compare to the process ranges. So process ranges ratio with the proportional band. If the proportional band is lesser and lesser, it's more aggressive output. Because the PB is a denominator. So if the PB get increased, its output is actually chopping, it's lesser. That's why it's like, okay, so now it's a 50, and my proportional band is a 16, so this is very aggressive, like this. So I said, okay, so start up, I'll just make the same as in a process range of 50. It's okay. Integral time, 30 seconds, who cares? Interval, I want to monitoring every 3 seconds. Saturation time, 30 seconds. And then look at it. As soon as we change it and apply it, all the current value will be shooting out this guy. Because we are now doing any more standard tuning. Apply. See? Boom. Now we said, okay, there's no more standard tuning. You do this value only. And then they just copy right here to here. So now, even the auto tuning still calculating it, but they don't care. They're not taking it because you said don't take it.
What happens if you switch it back?
Just go to put it in a true.
But I mean, like, say you're on a job and I need this shit to happen now, right? So you tune in your way
Mm-hmm.
and you're coming back tomorrow. Can you flip it tomorrow to auto tune now that you gave it more parameters closer to what you're looking for, but then let auto tune take over?
It is, but think about it. It's like I cannot guarantee it. That's all depend on differences. You asking that, okay, you do this one, we do done this one. Then tomorrow you come in here, put into the flip to the true, and then this value will be changing it. But this value will stay there.
But that value that it changes to is more closer to.
Yeah, that's true. Yeah, but
Right? So
but
that's would that be
yeah.
best practice?
right. It's not a best practice. Best practice is the reverse way. Put the auto, let it run,
Okay.
and get all the value, and then those value here, current value, copy that into here.
Got it.
And then one port say that like, okay, now you want to test it. Then just you copy all this one into here, and then just put the false. Let it run, maybe at least in a couple of hours, see what happens. If that if you don't see any bumping, then meaning is that value is maybe nice. But still, for the long term, what if that some external reflection is happening with that system? Then is that going to be perfect? I don't know. Yeah. So.
So if you turn tuning off,
Uh-huh.
will those current values stay until like a power cycle, or if you don't put them in the defaults, or does it automatically go back to default?
So automatically go to default. If you say it's a false here, leave it here. Now you recycle the power. This value will be there.
But if you don't cycle power, will it keep the current tuned parameters in there?
So if you go there now, go edit. I say, oh yeah, I don't want to go. I want to go for the auto. See, this value is still there. But look, they changed it. See, now they start they start taking from the prac tuning calculation. Instantly, they take it, okay, this one is okay. Oh yeah, 54 more, this is more proper value, and so on. And you snapshot this one, and then you're changing value, and then maybe I just input maybe a flipping up and down again. This value will slightly maybe change it again. It'll keep changing it. That's the auto tune.
How long should you give the auto tune before you switch your values? A day, 2 days?
I usually half day. I mean the critical one.
Yeah,
Yeah, just like, but the rest of a handle unit, just for like a cooling valve, put in the condition to cooling valve, just maybe an hour.
Okay.
Yeah. Yeah. So that's the way to do it. So one thumb rule. You don't want to involving with saturation time, integral time. Just okay. I already sent you yesterday the PID prac tuning guide. Just read it, and it'll explain to you exactly what is that meaning is. And then sometimes you will see surprised that it's like, oh, CCT don't care that value. You'll see it. But anyway, most things you have to see it is a effective period time. It's the interval time here. You control pressure, water pressure. You want to do the fast control, right? Then you have to reading fast. So 3 seconds is recommended for CGM. That's the shortest time. If that require less than 1 second, then now you have to using some other controller, which is, we never see in HVAC side, but I do see at we have a few mood manufacturing, Johnson Control has acquired the TriTac, and the TriTac is a fuel mood manufacturer. So they have to control everything. They have to control within 3 seconds. Any reflected pressure, they have to be controlled. The damper has to be, that is a fuel mood control, and it's just kind of adjusting the damper position to maintain negative pressure in that area. That's why we're using the fast actuator, 1 second responded, and then we actually see it's the same as a CGM. Oh, you guys got the white one, but the black one that branch using it, M4 this is CGM 09090. They all look shaped same, but I actually just recommended the changing the another processor, so it actually picking up the 1,000th of second of the sample time. So that's it. That's the 3 second. I recommend the 3 second for the water pressure, any pressure, or even flow. But here, effective period here is a 12 second because we only give one command and we don't care now. Right now, we are doing this one, but actual reality is what? It's going to be, value is going to keep changing, right? Anything swing, small move, it'll change it. But the 12 second, yeah, maybe it's okay. Because they said it's a 12 second is enough, and the 3 seconds may be too aggressive.
So the effective period would get copied into the interval?
No, actually, unless this one is like only effective when you change it to the false.
That's what I mean, if you were copying those.
Yes, please. So now this one is done, and then you say, okay, I think that, oh, this is, kind of, done the commissioning, and then please, this value right here, current value, that one, put in the spreadsheet. Each project you guys may be handling those things, the project sheet for the PID data, and make a tab for the say, okay, chill water valve, and then put this value there, and then, if you're nice, just copy all this value to here, and also even here, on the default side. That meaning is now your loop is validated at that date. But if you go back out there someday, maybe after a month or after a year, that this current value may not same as at the initial commissioning time value. So, because it keeps changing it. Because it keeps changing within somehow maybe one day, maybe everything was fine, but someday maybe it kind of, just maybe more aggressive, maybe happens, so valve maybe open more fast and, so on. And it could be caused by something else. But what I'm saying that is like, at least you have that, default value where that you already commissioned. That is more trustable value, isn't it? Than, But also that sometimes the customer said, oh, some smart customer, and he think that the once you tuning is nice, only happening when is it changing is what? Something that happened, like a pump failed or something happened, right? So they said, okay, since that this value nice, they know that you guys did commissioning it and they checked out, validated, then they said, lock out. I don't want to do any more auto tuning, lock out. Then meaning is they want to lock out to false. Believe it or not, that if it's a guy that will ask you, he's really a very knowledge, has a good knowledge on that PID side.
His tuning reset can get kind of complicated though, huh?
Yeah, it is. Once, and usually like,
Complicate that process that we were just talking about.
yeah, I mean this can be a. Usually you don't see that much, but only you'll see when it's like a BSL up, like pressure side. I mean, this is like a life-threatening one, like a biochemical, their bio side. They don't have any excuse that that any air coming out from the lab to outside. That's why they have a double door and whatever. But still, they at the time, the tuning I done with the FEC. God tell me that it took me about a week to tune that things, to find the right parameter. Auto tuning, forget it. Never can be done because there's a fast response time. And we didn't have that fast processor at with even CGM it cannot. So what end up I done is like I actually do a lot of layer of PID to do that, but it's just I'm telling you, the auto tuning is the best for the HVAC world. But if you see something that really concerning about that pressure side, then you have to think about it. What is the best way to do it? Just pump differential PID logic is best. Even though that is not work out very well, then use it. This one, 3 seconds, and then process ranges. If there is like say 50 or 10, whatever, make the same value for the prop end, the 1-to-1. And if that's too aggressive, you can start increase more. And if that is that action is too slow, then decrease more. Decreasing it at the proportional band. Nothing else. Just play with only 2 parameters. 1 is interval, 2 is proportional band. The rest of them, don't bother much. Don't bother much. And see here, if process dead time is now 20 seconds, and then I just throw like a 10 seconds, and they can change it. But you throw that value, if you keep changing all by once, then you wouldn't know which one is causative. So when you target it, when you go to their simple pit loop tip is target the interval first. And then next, once that the interval, because you know that, right? If a pump start running, the pressure, how fast they are changing it. They're changing instantly, isn't it? Anything happen, that pressure just up and down. If VFD, pump VFD is slow, say bump it, the pressure is bumped. But if you follow all that instant happening, instant events, then your pit loop is going to go crazy. You're gonna hear, it's just like crazy. That's why it's like, I'm recommending 3 seconds, but old PID version was like old, like version 3, 4. We were maximum, we were fast that the recommended was a 12-second interval. And then after CCT, firmware version, after 12, or the 10, whatever, we start using the 6-second too. But we don't use much at the 3-second at all. 6-second and 12-second, and then zone is a 60-second zone temp control. So think that way. Okay, my process variable, they are acting fast when this source, the control source, is acting it. Then if that is fast, then put the 3-second. Otherwise, 12-second. And then process variable is just you can pick up, usually process variable is easy to calculate it because the target range minus whatever that settlement range is. And then usually use that value to throw that in. And then prop band, see here prop band, they recommend the 60.8. Meaning is what? They want to slower. They think this is too fast. So prop band is increased. I said denominator is increased, so output is lesser, chopping out. So if I put this, prop band for 100, and even though that, flow is kind of changing it, the output is not going to like 100, or 10 or 20. It'll go like 1%, 2%. If you put like a 200, it'll like a point some percent, and it'll increase very slowly. But if you want a fast swing, then you can bring down less than a process ranges. Then now denominator get the lesser. Then output width is going to be more wider and wider. So instead of 1% output, now is going to be jump up to like 50 or even 100 right away. Did it never see you guys? Did you guys see ever about it when you do the pump control one time? Whenever started it like go to 100, go down to 0, 100.
Usually it'll go boom, boom, and then just stop.
Yeah, but.
We're spoiled with this though, when you don't have the
Right, yeah, that's see?
differential.
Yeah.
Because I always thought it'd be kind of cool, but I've been using the Johnson stuff for like 4 or 5 years now, and but prior to that, I always thought it'd be kind of cool to use a span block to essentially write to the proportional band, so that when you first start up, you could have a huge
Right.
number, but the closer it got to set point, you could then, you know what I mean, you could
Yeah,
essentially
yeah.
bring a reset
Right.
to the proportional band value into the PID, but it's something that should be done on a bench first. I've never
Yeah.
played with the idea.
Well, the gentleman talking about is, I think it's, you're dangerous.
You know what I'm saying? 'Cause
Yeah, I know.
startup, you
I
can
know,
take
I know.
smaller increments.
Yeah. Anyway, that is the internal side. So actually we are doing that one, but sometimes it's not really keep up well. So, that's a different process side. When you do the really industrial side, when you do the really fast control, like, I adopting that idea into the tri-tech fuel mode. So has like a PID, all parameter, every parameter has a different phase.
Right.
Just as you said, is like if that is in like a delta is get greater and greater,
Yeah.
I get my parameters get wider and wider.
Yeah.
And then if that the delta is get less and lesser, that is my parameters, especially prop band and sample time, get changing too.
Yeah.
So yeah, that is the idea. But we are dealing with a standard HVAC. If you face with that some project that require those things, yeah, that's big money. They have to pay well. Someday you will maybe handling that the Tritech fume hood control, fume hood, but that's they shipping out to, all the mounting, all the controls mounted it, so you don't really have to worry about it. Only you may have to do just, just field check maybe. But anyway, so now, hope that you understand at least some of this one, but don't worry, just like play around. And PID to show you got the real exact value for all the parameter is tough. You need a real system. That's why yesterday I mentioned to you that I used, when I was in a branch operation, to teaching that all my branch people and the regional people that I bring around at the small handle unit that I built with acryl. Oh, it was nice, but yeah, then we can, I can show them the real hand-on pressure control, but simulation is tough. Simulation, you never want to get the real value, good value at all, because it's, the process variable, it's not real, isn't it? You have to just fake it. But
That gets kind of tricky too, I've noticed. I had a job where I had to, it was essentially a test lab, so they wanted to automate certain parts of this training area. So it got kind of tricky because essentially the update, like the update interval for our inputs was tricky. Meaning, I was really missing, like, controlling a bypass valve quite a bit because the input update interval was kind of difficult to deal with.
oh,
You know what I mean?
yep.
Like,
So it is a kind of a lot of noise or a lot of bump or what?
well, right, it was one of those where I was doing condenser water control and whether it was bypassing the tower or not and having those two things run together.
Yeah, it's
That
fighting
was-
each other.
Yeah.
Yeah. Oh, yeah, you mentioned that too. So especially that the one, okay, so that is really good things too, so we can think about it. Say we are controlling, say, I say this is just, say, say just, water line. Now you are controlling, of course there is like a source with a chiller or whatever, boiler, I don't care which one it is. There's a mechanical device is there. And they are controlling, right? They are controlling. And then they do have like a portion of that, the pump package right there. And then somewhere they have to say, okay, there's now the secondary pump. This is a primary pump and secondary pumps package. And then they even have in the primary side, they could have that the bypass valve, whatever. So now, in one main resource has multiple different possibly control package. So now, if that fall into your project, how are you going to control even secondary pump speed when these two are not reliable? No way. That's why when you control it, do target first close to one from the main resource. If you have a primary pump control on chiller side, do that first. If you do have a primary bypass valve, do that first. So pump first, next disguise. If you just try to do, say, okay, it's done, but something happened. If you're targeting all three at once, no way. They are fighting. You overriding valve for certain position, and then this guy will do different action, and then this guy will do different action. Because it's all what? They are all depend on the one line, which there's one main resource line, water flow. Same as at the end of the unit. VAV, You are doing now commissioning VAV, but you know that handler unit commissioning maybe are poorly done. So handler unit is like a swinging. Every time, you know, your boxes, you know, some boxes changing it. You know, if that thing is swinging, how are you gonna commissioning that, you know, boxes? No way. So you have to commission main handler unit first. To do that is usually what? A lot of people, a lot of my even tech was kind of slightly, you know, misunderstood it. That is, I asked them, how did you commission that the handler unit? And they said, oh yeah, you know, just run the, you know, I throw the CAD file, and then just, you know, wait for, you know, several hours, and then everything was fine. So I just move on to the next. I said, oh my God, did you open the box all 100%, whatever that thing, all in line? Did you all close it? Or did you open the, you know, 50%? No. Then how can he control? I mean, how can the air handler unit can find the right, good, all PID auto parameter? Right now, it's like it's the same thing, this one, but the same thing is in the air handler unit. Say this is the main AHU, and you're putting out a bunch of the boxes. So, to main, you know, tuning, right tuning, get the value for this one, I usually recommend to say, open up all the boxes to 100%, wide open. And then run this one and see that what's the pressure, the static pressure reading. And then change that the set point from up and down a little bit, several times. And then if they pick up well, good. Then now, so I usually tell them, bring down the speed to minimum. You mean is a set point, bring down the minimum set point. And then I said, close this box 50%. And when they're done, I said, close the, you know, all to the zero. Just, you know, not zero, but, you know, I said, close to, at least, you know, close, you know, manually overriding all the boxes, say 10%, whatever. And then let us see that how it work. And everything is well, they, you know, because now all these cases, whatever in commission phase, whatever that we give that, you know, some value to change it here, position, whatever, damper positions, change it, this guy start learning. Oh, you know, now I have to, you know, it was same speed last time to maintain 1 inch. Now, like somehow something happened, so now maybe box is all open, so now I have to bring up the more speed. So that on those cases, the prac in that handler unit controller, the CGM, whatever, they are learning. So they're getting new value. So if you give them like a several swing, different phase swing, then this guy learn more better. So that meaning is all that value that he calculated inside the CGM, whatever, is now already got the most possible scenario parameters there. Then you can go down there, start the commissioning the boxes. Do not ever coming back from, you know, the main resource. Same as the water side, same as air side, no matter what. Because it's water side, they are not the water only. They see this is all tapped by what? Same as the boxer. This is for AHU, fan coil unit, you name it. All boxes right down there. I mean, all units down there. If you don't if you're not commissioned well on this side, this is going to be also affected too. That's why the water flush command for all the handler unit and those things, they are, you know, using it. When you tune, I mean, when you commissioning main source, they says like, hey, open up all the, you know, valve, and then, you know, close the valve, open up the 50%, open 10%, open whatever, you know, just swing it. When you swing it, then main source will start learning. Oh yeah, this is okay. And then when they're learning, once they're learning all scenarios, 0 to 100% possibility, at least 2-3 times, and then anything happen in future, they know that value already, that parameters has been learned. So that value will be cover up those things. So, yeah. So, yeah, PID is just. That's why since after prac tuning, so Johnson got really pay a lot of investment to create this prac tuning, and then just like all the branch people was really relief from the stress of the tuning. Used to be DX9100. We have a tool, isn't it? We had a tool. Oh yeah, we have a GM. Whatever tool that we can tuning it, but still you need to sit down there watching it, and and then you need a calculator. Oh my, forget it. I tried everything, and I never got that really perfect. But with all, year by year, when I get the more experience and hands-on experience on the field, later on, I said, oh, I know what the value is. Just throw it in. It usually worked. But yeah, that's it. That's why I say, if you want a genius on the PID kind of tuning things, okay, I already give you the answer. That is don't mess around with anything else. Just interval time and the proportional band. Then you are the guy. Usually, I'm telling you, more than 90% will cover up with the two value. Even you do the manual tuning. I'm talking about that is a manual tuning. Auto tuning, you don't even have to touch anything, because they just calculate internally. And here, in PID, there's another one. See here? Okay. It's all, every single of them is also described in the brochure that I sent you out. So manual tuning right there set up, right? Right now is a false. So now we're not doing, in the PID preprocessor is actually, it is just a separate processing object. Once you're false, it'll not taking any prac tuning value. Now, once you put that into false, now you come in here, you can set this manual tuning to truth. And then once they set the truth, the preprocessor is more likely same as when you see the CCT on the left column side, the input portion side, there's a miscellaneous, right? That preprocessor one is actually just like that one. They get copy from here. They get actually copy value from here. These guys are actually calculated. The main big PID block is actually calculate what is the effective time, what is the saturation time, what is the dead time, and those things here. And then they copy out there. So once you change that PID preprocessor side to the false, then they don't care anymore to bring it in here. They just copied it. But this one is still calculating it. It's okay, you can leave it. It doesn't matter. It's not hurting, because it's just sending the same value. But if you do not want, okay, I don't even want to adopt the tuning. I don't want to calculation anymore. Then you can go there, set the false. Then meaning is now your PID loop is not learning anymore, and just leave it there for the one, whatever that you put it in, it'll only doing that value. Is it hurt that to put the false there and then just leave it true? Yes, fine. It's just calculating it, but the pre-PID side mirror image go down there, it's going to be just, there they cut it. They don't take it anymore. They're just sending out whatever you define the value only. So that's nothing else. Yeah. And so that's always the input side. There is the output side here, still same here. And then there is a lot of things going on. Present value is 0%. Error is like, current error is a 20. Why I got the 20? Did I bring down that much? Oh yeah, 20. Okay, good. So sometimes you want to expose these port here, error port. It's a good idea. Expose the error port, and then do you know then is what the current error is? Delta from your set point. And then here's the saturation status. Hey, what is the saturation status? You guys saw every time you're programming, even VAV, there's a control status. That control status telling you that what is your PID, or what else was it? The PID plus that. Okay. Let's configure it. Stop it. What is that? The control side. Oh, here it is. See here that we have MSC preprocessors and PID. MSC process. Please read it. But the multi-stage control, same thing. But anyway, all those things, they actually using. If you go there, right-click, expose port. If you select, say, all, I select all, and there's a many port now, showing it, even outside here. So now, usually, the saturation status, we use a lot of saturation status. Saturation status meaning is what? Is how your PID does. So PID is right now 100%. 0%. And then still, value is like, process variable still on the lower than a set point. Then it'll say that, oh yeah, it is just lower, timing lower. Low, and then timing lower. And then now it's 100%, and then process value, maybe whatever, if direct acting is higher than set point, meaning is that even though they're pushing out the 100, if that is high, and then after time expire, it go to timing high, meaning is like, hey, I need more resource to bring down from the 100.
Like the MSC.
Yes. That's what, okay. So that's why when you go to look at that 800 unit mixture sequencing, whatever, anything, even John time sequence, 800 unit sequencing mostly. That's what the MIT guy was smart, so they use that control terminology to decide the when is, oh, wait a minute. So those guys are smart enough, so they decided to using that control status, that they want to do econ or econ plus mechanical cooling. That's what they done. How they done? If damper, when economizer mode on damper control, if damper control is like that PID is sending out that control status is timing high, then then I need econ plus mechanical cooling. Then leave damper wide open, open up the chill water valve. To me, that's dumb. That's wasting. They think that theoretically, it is a smart move, but practically, no. Customer doesn't like it. So that's what the control status. So when you created the CAD file from Q&A, you will see a lot of control status. I mean, involving into other logic. That is the how to compare what your target output is. If target output is require, if target output is in max and still is not, maintaining it, then, you're looking for some other source to do maintain that, that the target value. So you'll see it. You'll see it. Even VAV, you will see it. So anyway, so here's on all other things going on, but I said, please don't jump hard, don't get into much. Just leave alone with auto tuning, please. And if you have like another things like a GPM, water GPM, using like a discharge temperature is usually decent. DAT, process ID, and then another thing is like a low limit here. Low limit handle unit. When you create that from the CAM program, usually we throw it at the 25%. You can adjust at the value. But some case like, because you never create your own, then do not ever forget what is your low limit. Once that the system enabled, once fan's on, no matter fan is maybe not doing anything, maybe static pressure is, very well maintained, but always certain point that you want to do the minimum speed, right? Minimum speed is what? Sometimes a 15, sometimes a 25% they want to monitoring it. Then you have to be adding value to low limit here, PID low limit output value. Pump, never done that. But fan, yes, they do a lot. So don't forget that. Don't forget that. But once that in a Q&A, they will generate it. But if you some case, if you create your own 100% PID loop, please don't forget about the low limit value. Low limit value, if you leave alone, then when they satisfy, just like a pump, when pump is satisfied, it'll go down to 0%. The fan is why we do not doing that. If a fan is going down 0, say if a VFD guys maybe didn't give any low limit from their side, they usually do, ABV, whatever, the enforce they do. But in case if they don't, the fan will go down to 0. And when you go down to 0, guess what happened? Your current switch is what? Open. And then you don't get sensor. Now your command is on. No matter what, even the command on, even 0% stay on, but now you command on, but the fan is now went down to VFD to 0%, meaning it's doing nothing, no draw currents, then guess what? Contacts open, hey, you got alarm. That's why it's like, but I never see that any VFD agent supplier never forget about the low limit side. They always put the low limits. And the ramping time, even pump, even valve. Please check the cut sheets, even a three-way bypass valve or even two-way bypass valve. Any valve. Valve meaning is what? Actuator, right? Travel, what's the stroke time is. That's why I used to love that, I'm a pneumatic generations. I think I see a few guys here. I love the pneumatic. Pneumatic is just go right into it. And also very, very, very precision-wise, I think is even better than electric, these types of the actuator. But the maintaining cost is high, so. Anyway, just like now we are dealing with now is all motor. So we have to know that what the motor travel time is from 0 to 100 and then 100 to 0. So we have to know that, one-way stroke time and then all full stroke time. That is, you have to put in your brain to determine it, what is going to be a perfect interval time is. Now, like a VAV boxes integrate, VAV controller, that stroke time is 90 seconds. And if you start pulling out at the sample time for 3 seconds, what? That damper actuator is going to do? Try it. It is always moving something. Always. Because every time 3 seconds they're receiving the data and try changing it. And airflow is usually not that steady, isn't it? That's why it's going to be always move. That's why we ignore it. And then sampling time is maybe 60 seconds, 1 minute, every 1 minute. So sampling time, which there is a period here, interval, or in here they say the effective period, it is actually what? Analog input filtering. It's a filtering. Because if we get straightforward input every time, if we don't get the filtering, excuse me, it's going to be a nightmare. I've been dealing with the Tritech. Sorry. Oh boy. Tritech for like 2 years ago. I spent almost 6 months to develop that controller for the Tritech. Actually, the solution was a PIC, and then later on it was a M4 when they start come out. It took me 6 months to tuning it, actually, to get the right value. And it was a big challenge. It was really big challenge. And then I end up, oh well, it's not going to do anything. So I actually request using another processor, which is faster. So that's why now that called the CCE. It's just not CGM, but shape is the same, same, only name is different, but has like a faster processor, so sample time can go down to the 1,000 seconds, just fast. But we don't need those things. Once you get into those things, then I think your job's going to be changing for like a full-time, really control side guys. Not control side, programming guy side. Yeah, if you like it, just welcome to this world. This is headache world. I miss the branch operation time. That's more fun because you're going into targeting with big Hummer building. Now I'm facing with every customer only. Yeah. So, okay. So everybody know that how I built that for selection. That's just I usually choose for the standard pit loop. When I created it, I usually use this enumeration set: off, max, control, override. So that's another tip. Do not ever use that on-off two state. Oh, that is really well, it's okay, but I'm saying that it's very unprofessional. Please use that the four state at least. So at least what is that meaning is. On, yeah, on is on. And then, off is off, but the max is what? Some condition you need a max, just, max situation. And then control, and then override. When is override? When is this chill water valve is in override, you don't want to do the override. You don't want to calculate all the pit loop, right? Because it's overloading. That time you have to go to hold. Hold means what? Just get the last value and then click out, just it. So it'll stay at the last value output. Just leave alone. The max, I create, usually, max, they put the, constant float here and then 100 and connecting it. But, hey, I'm a control guy. I usually recommend to put like a maximum speed set point, that backnet exposed one, so they can change it. So whenever even max, they say, okay, I don't want to go 100, I want to go 80%. They can change it. and then put the rate limit here, rate limiter. Do something nice. You don't want a pump go down like, valve go from 0 to 100, wide open. No. Give them a rate limiter. I said 35 right now, but so 35 meaning is what? You're receiving maximum speed, say 100, input coming in. Now it's in the max condition. Then rate limiter is 35, so it's only chopping out to 35 times 35 changes per minute. So instead of going out 100, it'll go out like slowly, incrementally. If you put like a more lesser value, rate limiter for like say 5, it'll really slow. But sometimes that is a lot of help for the whole entire system, because it's not water slamming or steam, steam. Like a steam is like most critical one too. So rate limit, please use it. And then startup value. What is this? This is going out. Now startup value, I said, you come back here, do this. So whenever rate limit is started, they always are starting from sending out and then compare it and then go from next one. And so it's just kind of a staging up. And then from this condition, so now like it was in controls, and then suddenly they want a maximum state. It was in control, so control was say 25%, what, 50%. But suddenly that max condition happening, and then when flip it, see this LV is coming from where? It's coming from the outside, so that 50% of it starting from here instead of from 0 to 100 again. So it'll know that current status. That's why I like to use that startup value. Even in PID loop, I like to use that into this startup value. Why? Because now we are in control. Somebody overrode that valve for say, I have to check something, so 30%. Then it was 30%, but now it's back to the normal to control. Then this value staying, that LV is 30%, it'll shoot into here. So starting to recalculate from 0 to whatever, this guy know that, the last output was 30%, then it'll start from 30%, whether going up or down from 30%, not from 0%. But if you don't put the LV, last value, on the startup value, it'll be always start at 0. That's another tip for the PID. That's the really beauty, the last value. Please test your last value. You create a bunch of last value. Any pages, I don't care, any pages, just go there here. Bring into last value Boolean, bring into last value enumeration, and last value of float, and play around with it. And you will see, what kind of power these three guys has it. Oh, you will love it. How are you going to say now, like, you want to check that you want to check that my set point was the same as before, minutes ago, whatever, the last changes. How are you going to check that? You can create it. You have to make a latch and so on and timer. But one block, the last value, will know. You put the set point, put into the last value. Of course, you have to make some kind of logic, whatever. But anyway, just put the logic, that mux logic or any mux logic with a float input, and then you can just create that current value and last value. You can calculate the delta, and then you can use it. That is a lot of last value required when you do the programming. maybe I don't want to bring out another one, but it's just like, there's a lot of value you're going to see it. Last position, damper position, comparing to current command to compare to last command to set that, okay, if that value is not matched, we want to set the alarm or whatever, do something. Last value. So last value is we have this one here, plus in PID, we do have that the last value float. We slide into the PID future here in block. And this is guy that, same as the last value float. So it always remember, no matter what, even though this is, not anymore control, every time it's like now is come back to control from hold or max, they know what was the last value and then bring it here. And then they start from that. Yeah. And also if you kind of generously want to handle, if you want to do it more likely a real proportional way to handle, please expose that the direct acting port and then connecting, creating a constant Boolean and then go inside it. Because whenever you bring in from the palette is always a false, change the true, and put that some text in there. So after 5 years, you come back to that field and then just look at it, and then you don't have to go cruising. You don't have to go cruise to see that this whatever, because you're already there. The text is things. I'm actually my primary language is not English. I'm a Korean, and I speak Korean, Chinese, Japanese, some German. But anyway, they're all. Now even Korean, I'm bad. I'm bad on everything. So guess what? I really like that there's some simple description on anywhere. Because, it helped me. You open up the file and create from this guy. So now all this one here. Hey, what is this? That's enumeration to the Boolean translation, right? And PID tuning reset is come here. When PID tuning reset coming from the PID state generation, when they go to false to true, first 5 seconds, we call that the reset first PID. After 5 seconds, next second PID, and so on. That's how they done here. See here? If you go there. That's it. That first PID, reset first, second, third, fourth, that is like a staging after 5 seconds. 5 seconds. It's only shot of 5 seconds only. 5 seconds, 5 seconds, 5 seconds, 5 seconds. That's the enumeration to Boolean. But if you're nice, if you're just more generous, it's just why don't you put the text up here to reset whatever PID equal to true. I'm just making exaggeration, but anyway, like this kind of idea. Put it in, nice. And then whoever going to come and the next time to see that you open up the diskette file from the field, he will really appreciate your effort. Because there's this life-saving. Oh, this guy is really done well to understanding what he done.
So that should tuning reset. You set it to first, second,
No, that is usually, I didn't, you choose that the auto state generation. I mean, I didn't select that CAN program, but here, right here. If
Well, I'm
you,
looking at a can, like the,
yeah,
their single duct one.
yeah. So just go to the PID, tuning reset, adding one, boom. And then if you go, see that the connection. So auto tuning, this one is usually coming from where? It's from the network input, right? Did I made it up to tuning? Yeah, tuning reset right here. And then once the tuning reset come into it, see here? Once the tuning reset is come, and then this is a FSM, another FSM. But if you go there, look at it, see there's the last value anyway. So every 5 second duration, right? Transition time. Every 5 second, once that the shot is coming from false to true, it remember, okay, now isn't true. So first the PID, you have a 5 second to hold the true. After 5 seconds, it falls back to the false. And the second is after that 5 seconds. And third is after 5 seconds. So it is already, we created the logic in FSM module, in this PID tuning reset, that state generation table.
So on each loop, then you would have to select.
Yes, you have to, you don't want to say this is the air handler unit. You have a cooling valve, you have a fan speed, you have a, say, heating valve, you have like a humidifier, you have a, what else, you know, whatever. Which one you want to go set the first PID? I'll put the first PID for when doing, I mean, for the static pressure control, right? And then second, maybe heating and cooling, because they're not doing simultaneously, so you can do the second. And third, maybe something else, you know, if you think about it.
But Johnson default's smaller than normal.
Yeah, yeah. So, yep, just that's another thing. Like the same thing, you don't want to control at once for all these different groups. So we can give now the PID reset using that terminology. That this guys, when we want to reset the PID tuning reset, first the PID tuning reset, maybe this guy. Second, this one. Third, this one. So.
Do you have to define that?
Yeah, you have to define it. You go to the every logic, the pit loop. In the pit loop, I use this one for now, it's like just for the tit time, but right here. In a pit loop, I said, right now, anything abnormal, then it's true, but I say, okay, now you are on your first reset. Then meaning is like this guy will tune reset when that PID reset go to the first PID reset.
So they separated them in different commands, but it's every 5 seconds?
So 5 second lag. First one is a 5 second, next one is after 10, you know, so after maybe say 10 second then. So, and the next one is after 15 second, next one is after 20 second. Then meaning is what? They are not.
They're all resetting at the same time anyway.
Yeah, but because you left it that way, not if abnormal.
They're only like 5-10 seconds apart though.
Yeah, you can increase it. You can go there if you want to increase that duration width, pulse width. Come here, go to the view. Oh. Where is oh no? I should go to the view logic, and then here FSM, boom, transient time 5, and you can adding. So now, okay, oh yeah, this is good. Now I know that the pump. I mean, we got the pump and bypass valve. I want to pump first. Whenever do the tuning command from false to true from network input, then that automatically I want to do pump first, and next is valve. Then the time I want to give like say instead of 5 seconds, hey, I want to give like maybe a 60 second, or even minute or 5 minutes. It doesn't matter. Here. And pulse width. And then you can put right here, transient time. Now transient time is now the 1 minute instead of 5 seconds. So that's another thing. Yeah. So state always say like normal is a false, but anything is not normal, it go to say, oh, it is in the PID tuning. The black one, the default element, is actually connecting to the state table. Usually it's go to state table, but actually these guys, you can put into the every tuning reset here. Now here, so now I'm connecting to this link here. So what it does is like this reset, now I can change it, name that reset, first PID, go to true. I mean, if there is in the first PID sequence, then it's true. Otherwise, it's not true. You can separate out. I usually separate out in the air handler unit. I separate out for the static pressure control, as always, first PID reset. And then cooling and heating, second. And if I have a humidifier, that's the third. Because I don't want to do that simultaneously same. Oh, sorry, I missed it. First is fan static pressure. Second, damper. Third is heating and cooling. And fourth is the humidifier. Then, usually 90% of the even internally Johnson, they don't even just click tuning. Well, fine, nothing happened. Yeah, because it has been learned a lot of the pit loop. But if you are really concerning about that, the control, whatever you made a program, isn't it better to just maybe kind of a staging out all of them, especially pit loop?
First I've ever heard of this.
Oh yeah. Oh boy, that's good. Yeah. See, this is what this kind of class is for. I don't teach people. I never teach people. I only teach when my big top bosses, when they asking for it. When BP level people they asking it, then I'll do. Because I grown up from the field, so my training course is not well organized, because I don't have any just structure to do them. I just throw my idea. That's all. All I depend on my training is it depend on you guys to asking some kind of question. I'm telling you, this class is so far is the best class I ever had. I had recently I had state of Illinois, Wisconsin, San Diego, California, and then here. And so far, this class level is I think is tough. I told you I don't want to teach the basic courses. I'm going to tomorrow. Bless me. Told me oh. So, pit loop, don't scare anymore. It's just like even yesterday, MSC, once we play around with it, isn't it a little bit more feel comfortable than used to be? You keep playing it.
Kick at it and write your own.
Right, yeah.
Yeah.
I already started
We
it.
all agree.
Yeah. Last night I went to hotel. I had to do some other things, but I already started. Okay, now I'm going to make that thing into CAD file. So I started it, but I already done small portion. So kind of which one is the lead and lag determination? Lead lag determination by the alarm and runtime. So it'll come up soon. I think it's maybe even before that middle of November. I can maybe send you out. But please, I told you it's not validated, so you have to test it. Don't complain. Oh, I used that one, and then that guy is like, oh, well, it doesn't work. And don't tell me. Whether you're using one or not is up to you, and then when you want to use it, you have to validate yourself. So create it. Just create the one sample like me, just naming as like a training PID, and then select the custom program from the selected pages, and then just put a bunch of the PID and play around with it. You don't even need this input output. I don't even need this input output. Just play around with it. Simulate it. So, well, if you have like I think that you do. Don't you get some potentiometer? You know, just a couple boxes maybe, or from the let your company to buy it for you guys, and then just terminate into your CGM and play around with it. That is a real. You can see, you know, the PID is working. You know, the response time. You don't need output because you can just monitoring the output. Only you need is actual input. Potentiometer. Just potentiometer resistances, you can define that the flow too, right? It's not only temperature. You can define the resistances. Just put in here your, just like, you know, put anything like from this guy. Now I select the 0 to 10, but who cares? You select the resistances, and then spanning from the, you know, that, you know, value, whatever you want to throw out, and then just, you know, tweaking around and then see that this PID algorithm is really working well or not. And then you're changing that the interval time, changing and play around, changing the proportional band, play around. And if that two values now you are very happy with it, then start playing around with the time constant, saturation time, because all in that brochure. What is that for? Just play around with it. You know, just tweak one by one. Don't do it at once. Boom. Oh no, don't do that. That's really bad idea.
This will probably take you like 60 seconds. Can you start a new activity? I want to see something. Start a new activity with 2 inputs, like say an XOR block, and it's the timer. I can't. There's something wrong with the timer that I'm trying to use, an on delay timer.
Mm-hmm.
When I energize the gate, even though it's set up for on delay,
Mm-hmm.
nothing ever comes out of it. It doesn't just wait the elapsed time
Mhm.
and then trigger the. It doesn't work.
Okay.
I'm wondering if I'm doing something wrong.
No,
or if
no.
there's something wrong with.
You're doing in the simulation, right?
Yeah.
Your simulation usually don't work out the timer well. Simulation.
Okay.
So to the testing the real timer function, you have to actually throw into the CGM or any controller to test it. The timer is another mess. But so, well, let's do it.
I changed it to a timer with memory, and then just had a reset
Yeah.
input on it.
Yeah.
But okay.
Sure. We'll try. I don't know this. I never tried with that.
I brought it in from an old version, like a 10 point something version.
Yeah.
And so I deleted it and then brought it in from the palette again.
Uh-huh.
It's still not
No.
like in the version 15 here, but
Uh-huh.
it's still not working, and I don't
Yeah.
seem to understand why.
Yeah. Now we can try this one. Let's say I'm just making a 2 boolean. Even 1 boolean fine, but
I'm just doing it's just a first status.
yeah.
Status one. I just
A status alarm.
Yeah,
Okay.
right.
So.
But I used an XOR, so that way it'll go fail when it's handed too.
Oh, okay. So now then different story. Okay. So now input's gonna be enumeration. So the on and off. Just say just command and status, the same things. You know, we're doing a command and status check. And then status. So now I'm gonna using, because since that we just need a, the pulse, a boolean to testing out the faster. So I'm gonna select that command hierarchy for the boolean output. And then I go there. Sorry, I need a 2 enumeration. I don't need this one. I adding 1 enumeration, and then it's on and off. Good. Now, when it's off and off is a false. When on and on is a false. And all other, if they are not matching it, then it's true. This time is like I'm comparing even the command off or command on. Anyway, any command and status is not matching it, it'll send out the Boolean value for the true. So you link it and link it, and meaning is now true, meaning is what is a fail. Now I don't want to fail fast because maybe a current switch is need a time to energize it. So we give them a timer. So timer, I'll give you like expose port to startup. I mean the duration, and then setup. What type is it? The setup is right now pulse. Hey, I don't want to pulse it. You can go to on delay first, and then okay. We don't need a setup here. Anyway, it's showing up here. Go there, setup. You select it, and when this is happening, and I'll give you like, okay, I want, if that happening, wait for say 30 seconds. I say 50 seconds, 15 seconds, because we are in a hurry. So see, right now 15-second delay. So I'll put the 15-second here. 1.5, and I don't need any display precisions in seconds. Boom. And then now you're connecting it, and then output, I want to put the enumeration output on a normal alarm. So when this is happening, it is alarm. So I say like this is mismatch alarm status. And then I'll say normal alarm. And then you can just connect it automatically, convert it. The converters coming out there, middle. And then now to double check to make sure they are correct terminology has it, then double click it. When false, meaning it's normal, true, meaning it's alarm. So when anything is not matching it, for 30 seconds, they will create the mismatch alarm. And then I'm exposing out there. So now I'm simulating. So now I'm putting to the 1, because it's you.
15 seconds, yeah, it's fine to wait.
Yeah. But what I'm saying that when you're testing it to default to 5, usually default to 5,
Yeah.
then that's the cause of problem.
I stretched it out. It's still, I had it at like 60 seconds. Maybe I'll delete the whole
No. I told you some. I don't even know even this one in this release. I got like a
Because
CCT 15.
My latching alarm goes into alarm.
Right.
So I'm monitoring it, it goes into alarm, but I never see it transition to
Yeah,
alarm.
that's what I'm saying. Like in simulation, we always have that problem. Your timer is actually working, but you cannot see that it is a changing state.
I thought something was wrong, so
No, it's
everything that
not.
was tied together, I started breaking everything to try to rebuild just that module. And
No, now it's maybe changed. I don't know. It used to be like that. So we had a problem. We complained it, but nobody even cared about it. So now I'm going to send the command on. Now, is it true, right? It's a 15-second waiting. And then should we throw out to the true? I think I think CCT, yeah, after 14, I think they fixed that problem, but we'll see. I cannot tell. Because it used to be that timer is in a, see now change it, right?
it's okay.
Yeah, old CCT version, I think is a less than 10. The timer in simulation didn't work out well. But they actually do it, what's supposed to do, but it didn't tell that the true to go true out here. It always stay at the false.
I'm running 15.
Oh yeah?
Yeah.
Wow.
But the modules came from 10 too, you know, so when I brought.
Oh, no, you imported it. Yeah.
Because I had already built them, thinking
Right.
I'll just.
Yeah, you might have to redo
I'll just
it.
rebuild it.
Yeah,
But-
yeah.
While you're there, you should review how to connect to the physical output to that command. Link the physical output to that command block.
So you have to
Say you
use
wanna
the last
use
value.
BO.
Yeah, last
You
value.
wanna bring BO1 into that, or whatever.
Okay, so say supply fan command,
Fine,
okay? But the supply command you cannot bring from here.
okay.
So now is supply fan command usually coming from where? This logic here, fan supply duct pressure control, whatever. We'll just put in one more here. And then this guy, we usually connecting from supply fan on and up commanded from this guy to the hardware binary output, right? This guy. Now you have to create the last value for the enumeration, and then supply fan on off command LV. And then every time you create the last value enumeration, the default enumeration set is control status. So you have to go there, double click it, or why is it not working anymore? And then you have to go there, changing this control status to now matching same on off, off on, whatever, off on, off slash on, off slash on, off slash on. What's the difference in on and off and off slash on? I'll show you this one. So if you like this one, this one is off slash on is a only two state. If you leave it like this, is another hold. If no slash, there's hold. So please, I see this happen. I made it myself. You know, I was too busy and just collecting and why should not connecting it? That's happening. So careful. So now, this one we can connect. You can connect the same as output. Make a connection to the last value. So now, this value and then this value, they are same from. And then when you timer side, I can connect this command from supply fan on and off LV. Because it's not gonna give you that the output connection. That's why, yeah. So this is that, yeah, and then status.
So what are you using, on slash off or no slash?
With the slash. Yeah. Yep. And supply fan status. Whatever. Okay. Now you can connecting from the input side, supply fan side. That's it. So. Yeah, and then testing out all the timer. There is not only this one. We are now using that on delay, and then now, oh yeah, this one. This one was it? No, sorry. The even old version was working well. Only problem if you open up, export, the time remaining. This never worked in simulation.
Yeah, because I wanted to expose. I
Yeah,
actually
it never
exposed
ever. It never.
On something, so
Yeah.
you can see like the runtime to off. So like if there was still a pump circuit.
Right.
And I was just waiting for pump off.
Yeah.
time, I wanted to expose that so somebody's like, it's off. Why is it still running? And I just kind of brought it to the workstation to say.
Yeah. In the simulation, that never worked. I don't even know now, this the CCT now 15, I have it and see what happens.
So you have to define the interval change you want to see though, too. It all- default
Yeah,
is
every
0.
10,
Yeah.
every couple seconds you want to update how many.
It's just, simulation is always has a limitation. So now you got your toy, so you can play around with it.
I've not read that it bringing in those, when you upgrade to like CCT
I
or
use
whatever,
one of those modules, I've had
you
any
know,
trouble.
I just noticed the last couple days, cause I was started to think of, start bringing in those.
Yeah, I haven't seen any trouble yet.
And I thought, like, when I exported it, or, I broke it before I, cause I thought it was a good working module, that's why I exported it, and then,
See, sometimes when you import from the old version to the new CCT version, and they will ask you, you want to upgrade that feature, but some block, they just don't have that, the new one, then they're just sucking up the
Well,
old
they
one.
don't know what our customers.
Yeah, right, yeah, yes, yeah. Especially when you make it a full custom program, they don't know. So unless that you're using that some predefined that the logic. I need a more faster computer. I requested some more powerful computer, and they gave me the same of two same. They just gave me, I said, come on, I need a more better. Command on. Let's say it started. Boom. Now I got 15 seconds and see if this is changing it. See, not changing anything.
Well, you never changed your interval update.
Did I?
Did you change it in there? You
yeah,
gotta change that to
that's
one or
from
something.
zero,
Ah.
yeah, something other than zero.
Didn't I? I thought I did. Well, it's okay. I'm going to redo it. Used to be this simulation side is never worked it. So yeah, never. So it's just like, well, boom, true, boom, still same. So yeah, but it's So now it's popping up. Oh, look at it. This is now fixed it. Yeah, wow. It's jumping for 5 seconds. So
Yeah.
but still it's
At
better.
least it tells you
Yeah, it
something.
tells you. Yeah. Yeah, this is
You
maybe.
tie that to like a network output.
Yeah, this is good for like minimum runtime, minimum
Right.
uptime determination, how long it'll be there. Usually I put from the EGIO, we have that, EGIO is a lot better on the timer side.
Okay.
So I always create the object that what's the remaining time for the minimum runtime, what's the remaining time for the minimum uptime. And then, because the customer usually want to see it, because, hey, I commanded it and still running it, and I say, hey, there is remaining time for that, and then, it's good. Another good point. So don't worry, I will share this file to you also, so you can just poking around and see it. And let's have a break, and then we come back. Okay, now.
Yeah, I don't find myself using like command hierarchy a lot, and I need to start.
Oh yeah, command hierarchy is it is very handy, but if you start making a larger matrix, then it's get more confused.
And that's what I'm saying, that's like, because I've never had any training.
Oh really?
I started just
Oh.
trying to put blocks together to make something
Yeah.
happen, and I just couldn't, my brain couldn't figure out how to, I started watching, I started pulling, I would just build a standard application and kind of go in and try to figure out,
Yeah.
how to manipulate something.
Well, yeah, please, just using the command hierarchy a lot, and then, there's only two types. One is result is Boolean, or result is enumeration. So I use a lot, honestly.
I wonder why I didn't use state generation much. It's because I wasn't using really
That command
hierarchy.
hierarchy, yes. They're same.
Right.
Yeah.
So it's like, I'm thinking I have like a real deficiency in understanding state generation tables.
Oh.
And it's because my logic was never really including any multi-state points. I
Yeah.
was just essentially playing Plinko, you know what I mean?
Yeah.
My token was kind of falling down in the place where I wanted it. It works,
Yeah.
but it's kind of clunky. I was just trying to.
Yeah, we're gonna come back and do this one. See, I just testing out that tuning resets go to first, to second, and third, and so on. So maybe it's just a good idea to show them. All right. We got more fun today. courthouse, big courthouse. That was about, cannot remember when was it, like 7 years ago, 8 years ago? I don't know. But just like it was ready to open, but it was in a Christmas season also. And then Indiana police, the team supposed to be Indiana team is supposed, state of Indiana branch is supposed to be support that, but they have a problem with the lack of technical people. So headquarters assigned me to go down to help them. So I went out there and found a lot of things that they not completed, but anyway, it's done. And then that night I got locked out at the parking lot, and then just I almost get freeze about 2 hours until the cops come in and help me out. But anyway, state table is nice, but if somebody doesn't really think to arrange it, then it can be a nightmare. If that the priority went wrong, or that the function state mode is selected wrong, then you're in trouble. Because I'm going to open up that the one handler unit we were kind of slightly so last time. Say this one. This one is the most, I adding up that the G36 whatever, so it's kind of more complicated. But in the state table, there are nothing changing. So now I go to open up the state table. What happened is somebody out and somehow kind of more has a curiosity, so they change some here or there and select the wrong mod. And so when economizer is supposed to be temperature control, somebody put like here is like just ramp open, and so every time the economizer temperature wide open. Those things, when you create by the CAN program, they are usually working well. I mean, 99% working well on this state table. So do not ever even think about the changing it. But when you're adding your side loop in somewhere here, maybe say you adding side loop at the end, you're adding another future here and right after this one, and then usually side loop is what? They don't care much about the existing handler unit priority, right? So you wouldn't mark anything until come down to bottom that you adding some future for on, off, max, hold, whatever, and then create that maybe just a state selection for that devices only. All rest of them shouldn't be touched because it's existing one. But is there a worst to even adding here? That's not, isn't it? Because you're just adding on side loop, and then you can do the same thing that I just mentioned, Ted, is from the logic with the command hierarchy. And here you're adding one activity or hybrid activity and then create a condition. You don't even have to create from the condition of the state generation. Usually I do, maybe I just create it here inside the logic. Create the condition, create the table, the command hierarchy, and then create the internal hybrid, whatever if needed it, and then sending out the command. So there is a lot of things that you can do it, but it's a brand new project you're doing from the scratch. Yes, okay, you can arrange a nice state table, but if you kind of adding feature for the existing systems, and then just don't even bother to touching the state table, unless they're required, like related with the say, okay, that unit is related with the fan sequence, so I want it matching with the fan sequence, then you can add it there. Other than that, it's useless. Okay. Anything else that you guys want to look over? Because we are very well covered, and of course that after you walk out from these classes, when you go back home, you're gonna say like, "Oh, I should have asked this." Don't worry, you got my email, so you can email me. And yeah, I try to pretend always busy, so don't expect me to send you the answer right away. But I am busy. So. I'm lucky that I can share time this week here, because I have to support internal, external, everybody in Johnson, whoever needed it. I have to support the technical side. So it is lucky that also I can get away from that headaches. I'm really happy to see you guys. So I'm always running around, but usually I am staying at my home office, and so if you have some big question about that maybe the broader procedures they maybe get tied up too, right? So they have a limitation of manpower, and then you need something fast answer. Then at least you can throw to me. If I'm busy, I'll throw to another guy. But usually I know who I can throw to get answer faster. Because while I'm traveling, or if I'm involving with the end user customer, OEM side, I don't have any chance to answer your question. Because my customer usually, they are very nervous people. So when I show up, they want to hold my hand and stay on the next to me.
Don't let you go.
I was like, hey. But it's just, it didn't work out well. I've been doing this one very well. And CCT, I love it. If somebody take away a CCT from me, I'll cry. When I program another controller, like EGIO, I program first with the CCT. And then when I get all idea, I just translate to another language, that's all. Everything I start with the CCT. This is beauty.
Huh. You did it all, right? You've been with GCA a long time, right?
Oh, well, but, like I got a couple of guys that is, who's working in more while than me, but they don't care about CCT. These two guys only doing the hardware engineering.
But you like it better than everything else in the past?
Yeah, I like that. I like the CCT. This is a lot better. I've been seeing JC80 and the JC8540 DSC. Oh, DSC Cal one. Oh,
Yeah.
that is the worst one.
I started in 90, so.
Oh yeah, you
Menaces-
may saw that the Cal
Menaces
one.
just came out, but I had a service.
Yeah,
So yeah, it wasn't bad.
yeah, but you sure it wasn't bad? I was like a Cal one.
8540.
Yeah. And then GPL. Oh,
Yeah, GPL I liked.
GPL is actually, we adopted GPL.
Yeah, because
To the
if
Menaces.
you understand digital electronics.
Yeah.
I was in that, so that would have caught right on.
Yeah. Yeah, please, you just don't hesitate.